Time to get ready for some volume here for a test, okay? First thing you need to know to be successful with volume is some formulas, all right? Now, the key to your formulas here is not just to memorize them, but to kind of understand what they mean, all right? We're going to go kind of quick here, though. Rectangles, we should have area equals base times height, or if you want, area is length times width, all right? By the way, these are all equations. They all should be starting with A equals or V equals, okay? Triangle is half of a parallelogram or a rectangle, so it's half times base times height, okay? Circle or in circumference, well, we know that it's pi times farther around a circle than across. That's pi times diameter. Or area is 2 pi r. The area of a circle is going to be pi r squared. Okay? So those should be old news from previous years. Now the new stuff we've learned. Regular polygon is 1/2 times the apothem times the side times the number of sides. Or we haven't used this much, but sometimes you'll see apothem times perimeter. Okay. Volume of a prism, well, prism, we got to find the area of the base times the height. So remember that capital B means area of the base. It's not a length. This is base area. So you got to go figure it out, and it's different in all shapes, all right? Volume of a pyramid, well, that's 1/3 area of the base times the height, okay? And that works for cones as well, all right? Volume of a sphere, volume is 4/3 pi r cubed, okay? We do have special formulas for a cylinder. If you want to write it differently, we can say that it's pi r squared times h. But this formula is general. This formula works for all of it there, all right? Let's get into it now. Let's find the volume, and we're going to leave this in terms of pi. So that means we've done that a little there. We've said volume equals, it's a cylinder, so it's base times height, or we know a cylinder, the base area is pi r squared. So that's our special formula, because we're just finding the base area. Well, the radius is 8, because that's half of the diameter, and the height is 21. Now we want this in terms of pi, so we're not going to multiply everything. We're just going to multiply these guys. And that's 8 squared times 21, which is 1344. Okay, and there's no units here, so let's just put generic units. Okay, so there you have it. Here we've got a triangular pyramid. The base down here, there's our base, all right? The base is a triangle. It's a right triangle. It would help if you draw that right triangle out. The two legs, there's our right angle right there. The two legs that make the right triangle are 8 and 16. So the base area, since it's a triangle, it's 1/2 base times height, little b. So it's 1/2 times 8 times 16. Well, half of it. 8 is 4. 4 times 16 is 64. So volume equals 1/3 area of the base times the height. And so we have 1/3 times 64 times the height of 18. Okay. And, well, we know 1/3 times, let's see, 1/3 times 18 is 6. 6 times 64, that should be 360 and 24. 360 and 384. Okay, that'll work. All right. Now let's talk about some regular polygons, some regular prisms and pyramids. So to find the volume of this, we need the area of the base. Well, the base is a hexagon, top or bottom. So we need to break the hexagon up into some triangles. Remember, we got to look for that central angle. It helps a lot to draw this little picture. This is that triangle right there. So if we cut this little triangle out, this central angle here, there's 6 triangles if we draw them all in. 360 divided by 6 is 60. That whole thing is 60. Half of 60 is 30. All right. We need to know this half side, which we know that's 2 because that's half of 4. We need to know the apothem. Okay. So we got to find the base area, all right? So volume equals area of the base times the height, but the base is 1/2 ASN. Apothem times the side times the number of sides. So we got to find the apothem length here. So we could say tangent of 30 is 2 over A. After we cross multiply and divide, we're going to get A equals 2 over tan 30. And now we can find that apothem. 3.4641. So we have the apothem. And now it's pretty much downhill from there. The base area is 1/2 ASN. 1/2 times the apothem, 3.4641, times the side length, which is 4, times the number of sides, which is 6. That's going to give us about 41.57. And that's volume, so we're talking cubic feet. All right, so there we have a regular polygon on the base and a prism made out of it. Now we're going to do the same thing but a pyramid, and a slight difference. Now we've got the apothem. This is the apothem. So we're going to talk about this triangle in the middle. Draw the same figure, this partial triangle, but watch out what you label. We know since it's a regular polygon, all those apothems will be the same. So we know the apothem. And we're looking for x this side, or half side actually. So to find the angle, we take 360 degrees around the middle, divide it by 5, that gives us 72. Cut it in half, we've got 36. Okay. So we know the tangent of 36 is x over 3. Multiply both sides by 3. We get this. And let's see what that is. 21796. Decimal point right there. All right, so there we have the half side. So the side length is going to be 2 times that. And we get 4.3593. So now the area is 1/2 ASN. So the A we know, they were given there, it's 3. So the side length is 4.3523. And the number of sides is 5. All right. Now we're good to go. 1/3 ASN. And that gives us 21.76 there. All right. So there's first page. Let's go to the next page. Here we have some composite solids. So we got to decide what they're made of. Here we have a cone plus a half sphere. It's important to figure out what it is first. Then you can write a formula for it. Now, this is a little different. We know that this cone, this hemisphere, half sphere, it has a radius of 4, so that's 4. That means this distance here has got to be 6, because we know it's 10 altogether. So the volume of the cone is 1/3 pi r squared times the height. The sphere is going to be a half times the sphere, 4/3, times pi r cubed. Okay. Now let's just fill in some numbers. 1/3 pi times 4 squared times 6, and 1/2 times our sphere, 4/3 pi times 4. 4 is the radius of the sphere, cubed. Now we're just going to go punch that into our calculator, and that's going to give us 234.57. And the units are meters, so this is cubic meters. Always third power for volume. Okay. How about this one here? We got area of the base times the height, so we got a cube here. And so actually a rectangular prism. So volume is the prism plus the pyramid. So the prism is 4 times 4, that's the base, times the height, 5, plus the pyramid, 4 times 4, that's the base here, times 6. But since it's a pyramid, we need to have 1/3. Okay? And so that's going to come out to be 32 over here. 1/3 of 6 is 2 times 4 times 4. And then 16 times 5 is 80. 50 and 30. And so that comes out to be a grand total of 112. And that's going to be cubic inches. All right, one more problem. Here's an interesting one. We want to make a cone that has a volume of 200 pi. Don't forget that pi. A lot of people on this problem forget that pi. So we're going to draw a cone, just kind of a slanted circle. Okay. We're going to need two things. We're going to need the radius, and we're going to need the height. Okay. So the radius, we're going to pick. So first of all, volume of a cone is 1/3, and then pi r squared is the base, times the height. Now you need to pick one of these. So we got 200 pi equals 1/3 pi, and we're going to pick a radius. Now, since this is 200, you might want to pick some multiple of 200, or some factor, I should say, factor of 200. Maybe 10. 10's a great way to go. You can pick any number you want, all right? But that'll work there. Okay, this is a third times pi times 100. Okay. Now, you could get decimals and divide by decimals. Okay. But probably your best bet here is, well, you know what? Let's get rid of the 3 there. Okay. Let's get rid of this 1/3. Well, if we multiply this side by 3 and this side by 3, then we have 600 pi equals pi times 100 times h. And now all we need to do is divide by 100 pi. And 6 equals h. So we chose a radius of 10 and got a height of 6. All right. You can do it lots of different ways. You can also pick the height. In fact, on the other answer key that you may have seen, I think we went with the height and then solve for the radius. That works too. That might be a little easier. So 2 ways to go there. Lots of choices. You pick one and solve for the other. All right, work hard. Good luck.